Weightless versus freefall. Now, most people use the term weightless to talk about what happens to astronauts, but actually, weightless is a misnomer. It's not the most appropriate name for what happens to astronauts. By the end of this lab, I hope we can distinguish between this concept of weightlessness and, in actuality, what is freefall, and the process in which a body orbits. Let me remind you that weight is a force due to gravity. It's a force that an object actually feels because it has mass and there's another large body nearby, usually a planet. Now, Newton told us that this force due to gravity, usually going down, equals mass times the acceleration due to gravity on whatever planet you're on. So if weight is a force, weightlessness must be a force in which you have, or it must be a condition in which you have no weight. In other words, there's no gravity acting on you. Well, let's take a look. Now, this is an astronaut on the moon, and you can see he's out on the lunar surface, and he pushes down this tool, but he falls over. Okay, so does this astronaut have weight? Yeah, you know what? He's a highly trained scientist, and he still really has to contend with gravity, because the moon has a gravitational pull on him. Now, I think that this is really cool how he gets up. Watch. A push-up. He tries doing a push-up in order to get up. Now, this is probably due to the fact that his pack is pretty bulky and heavy, and if you've ever worn a pack as you go hiking, you'll know that getting up from a seated position can be hard. Well, okay, so astronauts, when they're on the moon, they have weight. What about this astronaut? And this is Dr. Nyberg. Is she weightless? And really, what's going on with her hair?
A lot of people ask me how I wash my hair and face, and I thought I'd show you how I do it. Let's see. To get started, these are the things I need.
Okay, if we take a look, Miss Nyberg, she looks pretty normal, but what's going on with her hair? Is Dr. Nyberg, does she have any weight? Does her hair have any weight? Because it's kind of like flowing all over the place.
A bag of warm water, a little no-rinse shampoo, towel, and my comb. What I like to do is start by just putting some hot water, squirting it onto my scalp. And I have a mirror here so I can kind of watch what I'm doing.
Check this out right here. Look at that bubble of water. Whoa.
And you try and catch as much as you can. And I just work the water up through to the end of my hair.
Okay, so Dr. Nyberg, does she have weight? Is the force of gravity still acting on her, and for that matter, her hair? The next person I'd like to take a look at is this man named Felix Baumgartner. And on October 24th in 2014, he had one very cool ride. On this day, Felix Baumgartner rode in a balloon up about 39 kilometers, and technically he is in space. You can see the edge of the planet here. He has one incredible view. Now, he's in a space suit. He needs a space suit to survive, and he's in a module, a capsule that will protect him. But once he reached the top, he did something that most humans would never think of. He jumped. He jumped from 128,000 feet, and he jumped into the record books. He became the fastest human being without the assist of a vehicle, and he reached speeds of 840 miles per hour, or Mach 1.2. He broke the sound barrier. Okay, at this point, Felix is falling towards the center of the Earth. Wait a minute. Does he have weight? Yeah, you know what? The planet is still pulling down on him. Now, depending on where he is in the atmosphere, air is pushing up on him as well. And when the forces of air up were exactly the same as forces of gravity down, Felix no longer accelerated. He was traveling at an incredibly fast rate, about 1,300 kilometers per hour, but he wasn't going faster and faster. Now, his mom probably wants him to increase his air resistance so that he slows down as he comes down to the planet. So in fact, when he actually encounters the planet, he's not moving very fast at all. Cool ride. But listen, Felix Baumgartner, he still had weight. What is common about all of these people is that they are in free fall. Free fall is a body that accelerates at the same rate as every other body around it. Now listen, if I were to stand on top of my bench and take one of my physics balls and drop it as I jumped off the bench, to me, the ball would appear to float right in front of me. To Felix, he was in free fall from 128,000 feet. And actually, Dr. Nyberg, she is in free fall as well on the International Space Station. And her hair is in free fall as well as she attempts to wash it. So, okay, here's planet Earth. And when Felix Baumgartner brought himself very high, did he feel a force due to gravity? Yes, and he fell towards the surface of the Earth, very much like everything that we've ever seen that has been dropped. And so he accelerated at negative 9.8. But my question is, what about Dr. Nyberg? Does she feel a force due to gravity? And she does. She feels the same force due to gravity as Felix does, but there's something different about Dr. Nyberg in the International Space Station that Felix didn't have. And that is that Dr. Nyberg is moving in one direction incredibly fast. And when you see that she's falling towards the center of the Earth and she's moving to the right in this case, very, very quickly, you'll see that that combination, the result of those two velocities, is that Dr. Nyberg kind of falls over the edge of the Earth. Now, is she feeling a force due to gravity here? Yeah, but she's still moving to the right very, very quickly. The result is that she continues to fall over the edge of the Earth. She does fall towards the center of the Earth, but she's also moving to the right or the left very, very quickly. And so, Dr. Nyberg in the International Space Station, she is in orbit. And the orbit is the process of falling towards the center of the Earth and moving incredibly fast in one direction. So fast that you actually fall over or miss the edge of the planet. So, in reality, who has been weightless? To date, so far, as far as I know, only about 24 people have actually experienced anything close to weightlessness. Now, when they were on Earth, they experienced forces due to gravity on Earth, and when they were on the Moon, they experienced forces due to gravity on the Moon. But in the meantime, between on the trip, in this situation, when they were in their rocket, this is about the only time in which you could honestly say that they were anything near weightlessness. The forces due to Earth were very small, and the forces that the Moon had exerted on them were still very small. And to be honest, the Sun was applying some force, and every planet in the solar system was applying a force, but these forces were incredibly small. So weightlessness is very, very uncommon. Free fall is very common.